Hi everybody, welcome back. Today's lesson we are working on analyzing graphs of quadratic functions. And I have two learning targets for you with this lesson: to be able to write quadratic equations in vertex form, and then also to be able to just analyze those quadratic equations when they are in vertex form. So first of all, here's a new form, a new way of writing quadratic equations. This is called the vertex form, and it's called the vertex form because HK is called the vertex, okay, and x equals h then is the axis of symmetry. So we have a term here, x minus h, and then plus k. This term is squared, and then we may or may not have a number in front of that term that is squared. So a little bit of terminology that you're going to see that I want you to be familiar with. The very most basic form of any function is referred to as the parent function. And in quadratic equations, the parent function is y equals x squared. It's the most basic quadratic equation there is. And so then we do different transformations or different things to this equation to get other equations. So we're going to be doing three different kinds of transformations. We will be doing translations, which are just slides that are either up and down or left or right. We will also be doing dilations, which will make the parabola either wider or thinner. And then the last thing we'll do is reflections, and those you're a little bit familiar with already. So let's start out with a translation. A translation slides a figure without changing its size or shape. And the values of h and k are what change when we're doing translations. So the parent function starts out as y equals x squared. And then if we take h and it is negative, so if we add something here that's negative, so it ends up being x plus a number in here, that means we're going to the left h units. And if h is positive, we go to the right h units. If we put a number in for k, and k is negative, we go down. If k is positive, we go up. So just changing those two things will make our parabola either go up, down, left, or right. A dilation actually makes the figure change its shape, and the variable a makes the graph wider or narrower. So if we have a value of a, so if there's a number in front of this x minus h squared term, if that number is a whole number bigger than 1, that makes the parabola get narrower, just the opposite of maybe what you might think. It makes it thinner or narrower. But if the number is a fraction or a decimal between 0 and 1, greater than 0 but less than 1, it actually makes it get wider. And I know on your notes this probably doesn't appear as clearly as it does in the video. So if you want to make any notes on this table, this is a pretty helpful little table here. And I know the colors help. The blue is the parent function on all of these. It's y equals x squared. And then the red and the green graphs are different transformations of the parent function. So I mentioned that you are a little bit familiar already with reflections, and that happens when a changes sign. So if a is negative, then that tells us that the parabola opens down. If a is positive, then it opens up. So let's look at some examples. I want to analyze this quadratic equation. I want to draw its graph. So the first thing I want to do is write it in vertex form. So to write it in vertex form, we need a x minus h squared plus k. So that tells me right here that the value of h and k are -2 and +1. So the transformations here, remember I said if h is negative, that tells us that we're going to translate it left 2 units, and k is positive, so we're going to go up 1 unit from the parent function. So now we can graph the function by plotting the vertex that we know, and the axis of symmetry is x equals -2. And so I have a picture of that for you here on this slide. So feel free to pause this and draw that in. So if we want to write the equation in vertex form and we're starting with standard form, here's the process that you're going to follow. The reason we did completing the square first is you're going to use that now to write your equation in vertex form. So here's how we do that. This is our goal. This is the vertex form on this slide. And I've given you two equations that are in standard form. So the very first thing we want to do is complete the square on this. So I'm just going to move the 5 out, and then take half of your linear term and square it. And on one side, you're going to add it, and then you're going to subtract it on the other side. We're keeping this number on the same side of the equal sign, and that's why we're adding it and subtracting it rather than adding it to both sides like we did when we completed with the square. So when we're actually not adding anything. Okay, we're just writing it in a different way. So now this is a perfect square trinomial. We can write that as x plus 4, the quantity squared. And then these two combine to give us a negative 21. So now from that, we should be able to find our vertex. That tells us that h is negative 4, because this has to be a minus sign, right? So it's negative 4. So h is negative 4, k is negative 21. And it tells us that we are translating left 4 units and down 21 units. Our vertex is negative 4, negative 21. Axis of symmetry is x equals negative 4. And a is equal to 1, so we know that this thing opens up. And so if we wanted to, we could go ahead and do a sketch of that. The next equation over on the right-hand side, to put this one in vertex form, what I want to do first is factor out a negative 3 from the first two terms only. And then keep the negative 1 outside of the parentheses. And then what we're going to do is do a partial completing the square on what's in the parentheses. This one gets a little bit confusing. So keep that negative 3 out there. And then half of 2 is 1. So we want to add 1. But when we distribute this negative 3, really what we're doing is subtracting 3. So I want to add 3 out here. I would just write that as plus 3. That's a little confusing right there. I'm really subtracting 3 here, so I want to add 3 on the outside of the negative 1. So now I can write that as negative 3. This is a perfect square, x minus 1 quantity squared. Negative 1 plus 3 is a positive 2, and now it's in vertex form. So this tells me that h is 1, k is 2. So that tells us our translation is to the right 1 unit and up 2 units. The vertex is 1, 2. The equation of the axis of symmetry is x equals 1. In this one, a is negative 3. So since a is negative 3, we know that it opens down. And this value is a whole number, so that tells us that it is narrower than the parent function. It's a little bit skinnier. In this example, we want to go ahead and write an equation just from the graph that we have. And the only two pieces of information we need are the vertex and one other point. And that will allow us to come up with our equation in vertex form. So we have the vertex equal to negative 1, 4. That tells us that h is negative 1, k is 4. And we have the point 2, 1. Well, these are x and y values. And so we can plug all of this into our equation to solve for a. A is our only unknown. We have a coordinate for x, a coordinate for y. We know what h is and we know what k is. So plugging all of those in and simplifying, we end up with a value of a being negative 1/3. So I'll let you follow through the math there. Feel free to pause this at any time if I go too fast. So the vertex, we have the vertex is negative 1, 4. To write this in vertex form now, we know what a is, so we're going to have y equals negative 1/3, and then x plus 1 quantity squared plus 4. So in this form, just substituting in for h and k and leaving our x and our y in there, and now that we know that a is in there, we can plug that in as well. So there you have it. We will go through a few of these in class tomorrow, and we'll see you then.